Okay, great.
Hi. So what I'm gonna do today is just to show off our last our project for the second assignment last year. Just to sort of give some inspiration for what you can do for your assignment. We made, as Christopher said last session, we made a sort of model viewer program with the features that you could actually modify all of the assets at runtime and reload them. It was sort of a tool to just see if we understood the concepts and yeah, whether it was at all possible to make such a thing. So yeah, I guess let's just jump into it. We'll execute the program with the demo scene, and we get this nice scene. So we have the camera controls, we have some stuff rendering, and we have a clear background, and we have the error. So this was actually intentional. I wanted to just start off with a really bad sort of scene, which doesn't really work all too well because, well, there's some errors. So let's see from the program printout, if I can actually use the scroll wheel on this mouse, if we have some error printouts. Doesn't appear we do, but fortunately I know where the error is. It's within the scene. So let's see. Demo YAML. Do you have Adam? Yeah. Nice. Good. So I I bought an adapter actually to get my own computer connected up to the systems here, but that adapter didn't work. So yeah, I brought in a friend's computer instead, and it should probably work on this one. So here we have the demo scene, pure YAML format, and well, it's just sort of describing the different properties of the entities, as we call them, in the scene. So we have a camera, just the one. We have two entities. We have 0 point lights. We have a sun. We only set the program's abilities for having one sun, so no multi-sun system supported. And we have relations at the end. I'll go through all of these and sort of explain what they do.
It's also explained in the repository?
Yeah, we also have the repository. I could probably find that if you have, yeah, perfect. So naturally we named our group Overkill Studios because we sort of made it a meme within the group that's how we always go sort of out of scope and do crazy stuff.
And the acronym is OK, so it's the OK engine?
Yeah, it's the OK engine. Really OK. Yeah, so this is what we expect from your README after the second assignment. Just sort of an explanation of everything within our system. And I'd like to go through all of this, but I don't think I'll sort of take the time today to do that. But yeah, some key points, I guess. We have additional syntax for shaders, so you can do more stuff with your shaders and have sort of control on the drawing stuff for each of the different shaders. We have our own model format because naturally using an established standard is for yeah, that wasn't overkill enough, so we had to establish our own model format for everything.
What's the advantage of your own format, right? How do you justify that, apart from trying out creating your own format?
Yeah, so if you've been working with the labs so far, you've probably seen sort of the vertex definition, and it's pretty much just this. We list out each of the components of each vertex, and it's in the raw format. And so we had a really strong connection between what we had learned in graphics and what we were actually working with as model files. And so it was pretty easy to be able to go into the model file and change around stuff in order to reload it and have well, the model be as we expected, instead of having this sort of amplified or rather vague connection between what the model was and what we internally had as a model. Yeah. Anyways, that's the reading. Let's go back to this. So we have a scene. We have an error. Let's fix that error. I think it's because we have a dragon that is actually a sphere. So let's change this to me, because I'm obviously a dragon. And then reload. Oh. Or, well, perfect.
Yes.
So this model is loaded. It's kind of in the wrong orientation, but
Well, they can fix that too.
we can fix that too. We have
That's the X rotation, isn't it?
I think it is. Let's try it. That was the wrong direction. So sort of on the right axis, I think. And as you can see, I can just hot reload by pressing, well, you can't see that I'm pressing the button now, but I'm pressing 4. Yeah, it's it has angular velocity on the wrong axis, so let's reset that. And I think it should be this axis. Let's see.
50.
50. Yeah, I'm so huge I can spin fast, right? There we go. But I can fix the scale as well, of course. So it's the mouse is kind of. I'm not used to working with a mouse, so this is why everything is okay. That's better. So we have me. I'm shaded with sunlight, and have some subsurface scattering, or kind of subsurface scattering applied to the shade as well. But just this is kind of boring, right? So let's add another entity. Let's add a light. I've sort of prepared this, and hopefully it should work. Let's see. Okay. We have a core. That's just an entity without any model. We use those for sort of making the scene graph work out in order to like parent the different entities to each other in different relations. So just now I've made a core at the center of the scene with angular velocity, so it's just spinning around. And if I can go back down, oops, that's too far.
So it's basically like parent objects in Unity.
Yeah, very, very similar to those. So let's add a light. Might need another entity. And because we wanted fast load times, we have sort of these headers before each of the different components of the file. So we have to actually change the number of entities now because we have 4 entities as opposed to 2. So let's change that as well. And then go back. So we have a point light. We want to enable that one as well. And if I reload now, it should hopefully work or not. I'm going to crash the program. That's fine. Let's see. Do you have any logs for this? Error. The key was different from the key out. So we wanted a point light. I gave it a point light, but maybe it found this one as well. Let's see. So there's a few parsing errors, so we need to restart the program. So, like, okay, we've reloaded the scene for like, I think we reloaded the scene 5 or 6 times before this. So essentially our reloading system works most of the time. So sometimes you need to actually start up the program anew, just because of this kind of error. I made an error in the scene, right? Mm. So we have a point light, but it's just sitting there, and this is sort of supposed to be the point light, but the point light is over there. So what's the deal with that? Well, we haven't really set up the relation between these entities yet, and that's the point down here, where we have relations defined. So this is kind of a bit more tricky to actually explain, and I think you might have a better understanding of this, but let's just see if I can try to explain it first. So I'll enable a few of these. I'll go over them after, so we need this one as well.
You need to remove the green comment over it, or it will parse incorrectly.
Really?
I think the hashtags break the parsing, doesn't it?
Shouldn't, but it did last time, so that should. I think this should work though. So, okay. Is this number correct, or do I need to set it as 5?
No, I set to 3, because you have 3 relations that, I mean, red is a relation with 0 entities in its relation.
Right, right. So the relation is kind of a definition of how each of these entities are are connected to each other, or parented to each other. So there's also an ordering aspect of this, so we need to define that, oh, red, in order to have a relation on red, we need to say that, okay, red is a thing that you can relate to, but red doesn't have any relations, so we define it as 0. And red is just a point light, so that's the entity with the point light and the position set to 0 and stuff. Then we can relate to that from light 1, so light 0 rather. Light 0 has one relation, and it's the red one. So now we've parented red to light 1, or maybe this should correct that. Okay, yeah. And then lastly we have core 0, which is the center point. It's connected into, by the way, can everyone see? Or is this kind of really small? Should I zoom in a bit? Is this better? Okay. Thanks for not yelling that aloud. Yeah, so I think we've set up the relations correctly. Let's try to reload it. Okay, there we go. So now we have our moving point lights that moves around the scene. Cool. And we also have sort of the specular lights and stuff of the material down here.
So just, I think, to contextualize, right? I think no one has heard about scene graphs here yet, right?
Right, that's true.
Do you guys know what scene graphs are, roughly, intuitively?
So,
yeah, what's scene graph?
How many of you have been using Unity for anything? I'm just sort of relating to Unity because that's what I'm most familiar with. And scene graph is basically the kind of hierarchical. I can't even say that word.
Hierarchical? Or is that a
hierarchical system?
I know what you're trying to say.
Yeah. You get what I'm trying to say, right?
Why do we need a hierarchical system?
Why do we need it?
Mm-hmm.
Well,
just asking the opposite question.
Because you need to be able to transform objects, and you can't transform all the objects in world space because that would be a pain in the ass.
Yeah.
So you make a scene graph, so you say that, well, there's a world and there's objects in the world, and then objects can be child of those other objects so that they can have that parent object as their world space. Yeah. I guess.
So to put it in practical terms, see that model there, right? So that's Halvor. Actually, if you go closer, it's actually Halvor.
Yeah.
And he's kind of very transparent personality, it seems. But apart from that, so for example, if you model the arm, right? You take him apart and you model the arm movement. Well, the arm is physically attached to his body, right? So even if you, for example, he would bow, for example, or sit or whatever else, the arm would necessarily move with the body, right? And by developing a scene graph, you model those relationships explicitly. So you don't need to worry about, okay, if you, for example, have a bowing gesture, you don't need to remodel how the arms move, you don't need to remodel how the head moves, you don't need to remodel everything, basically his jacket and so on. But because the jacket and arms and so on are attached to his torso, if the torso were to bow, everything will, follow that movement, right? So you only model the primary component of interest. And that's the idea about a scene graph. You develop relationships between everything, so that you only ideally need to modify one particular, characteristic, and it would reflect all dependence. So everything that is, think about it like a tree for now, right? So everything that sits below that tree will be affected by it as well, right? So if Halvor is changed, everything that depends on Halvor is changed as well, but not the rest of the world. And this entire graph, or this tree for now, as it's represented internally, is called a scene graph, right? So if anytime he's talking about relationships, he means precisely that, right? So if he wants to color something, you identify your object and make it red, right? So, so if you have a red color attached to multiple objects, you change the color, all the objects will change color as well, right? So that's the kind of abstraction they have tried to model in this project.
Yeah. But that's sort of, okay, this is scenes. Let's talk about some other assets. For example, this plane down here. Because right now, that's just a simple plane with a texture and some fancy lighting effects on it. So if I can just find the different assets. So we have all our assets gathered in an assets folder. Just as we went in the labs, we have the resources folder.
And similarly to Unity, you have everything in an asset folder.
Similar with Unity again. We sort of tried to model some of these things after Unity. Let's go into models first. Let's find this plane. Let's open into that. So, as I mentioned earlier, we have a really the model format is exactly this. It's plain sort of vertex format as you would have had it in OpenGL and in your C++ code. We have the vertices, we have 4 of them, and we have one mesh, and it's called a plane, and so we can refer to it as a plane, and it has a material, and it has a shader, and it's constructed of these 2 triangles. So let's try to do something crazy. Let's change the shader to, if I can remember the different shaders. I think we have one called standard. And I'm not really sure if it's textured at all, but that would be interesting to see. Apparently it is just the same thing.
You can change the color of the vertices on one side.
There we go. Oops.
Oh.
Yeah, so the, yeah, cool. Why is it changing to draw on the underside? We'll come to go into the shader and find that. So shaders, we have the standard shader. Add-on. And let's also open the base shader, which was the one we used before. And okay, so the standard shader is pretty much just, well, it's a long shader with a lot of deprecated code in it that we left there for some reason. But we also have the base one, which has these things set up top, which is the additional shader formatting I mentioned earlier, because with the base shader, you can basically turn on and off different OpenGL features. So depth testing, culling side, and the blend function. Those are the 3 we sort of defined to be within a project. So if I just go to the plane again and change it back to use the base shader and reload. So that's just a hot reload of the model again. And we go into the shader. I can set depth testing to be off. If I can spell that correctly. There we go. And reload the shader. Doesn't really appear to be, whoa, okay, it does something, right? It doesn't care really about the ordering of the objects in the scene. It just draws, regardless of what is possibly in front of it. So now, even though I'm in front of it, it sort of draws on top, right? And so that is what the depth testing does. And this is basically just you can do the same thing in OpenGL by just calling GL enable or disable Z-test, I think. Enable, and it's like GL. I can't really. So you do this to sort of do the same thing, right? And what we've done is basically try to map these different enabling and disabling features of OpenGL. We wanted them to be available through the shader, so the shader on its own could decide whether it should do these things and or not. So yeah, can turn that back on. And then we can change the culling, which was the effect you saw before. If I change the culling to be off, for example, and then reload, then it's going to draw from both sides because it's not culling away the back side of the blade. And you can also do sort of the opposite of what we had before. We had on back, I think, right? Or on front. Oh wait, so we had on front before, but now I have on back. So it culls away the back side instead of the front side. And the back side is, well, the upside, I guess, this mesh. So back off actually, because I want to show another thing. We have the last one, which is the blend function, which is if you want transparency for your objects, you want to deal with this. So I think it's source alpha and 1 minus alpha. If I go back, yes, okay. So now it's drawing sort of transparent, right? Yeah, you can see myself. Good, nice. Let's not have me be the dragon anymore. I'd rather use the dragon as a dragon. So let's go here. And reset all of these properties. We mentioned the site yesterday for these sort of standard models you see in programming, or graphics rather. Here we have one of them, the Chinese dragon. And this was sort of, we added this just to do a stress test of whether our system could handle such a model, because it's a really big model.
How many vertices does it have?
Doesn't the default say? Isn't the checking?
That might be true actually.
If not, I think the model says it on the bottom, right? So the model explicitly says how many triangles there are.
So just to put things into perspective though, if we go into this assets and go into models, we have the dragon somewhere. It might actually, yeah, gives us this. Atom is trying to open a really large file. It's fine.
60 megabytes.
Yeah.
Right?
So this is kind of the file you wouldn't go into and change the model around, but you can. So like, let's do that. And we go to the models. Maybe you'll see this, maybe not. Yeah, I think.
Oh yeah, there it is.
Nice.
The one
Beautiful.
Yes. So now you can remodel the entire thing just from this this file, right?
So if you go to the bottom, how many lines of code is it? That means how many vertices?
Go to the bottom, that's the right order.
Control.
There we go. So
yeah,
let's get an appreciation. There's
That's
something else there, right?
Control T triangles or Control F triangles. E triangle. Yeah.
There you go. So 430,000 vertices, right? Just to get a feel. That is a lot.
Yeah.
Who disagrees? That's a lot, right? So yeah.
But of course we've not covered everything yet. We have the materials left. And well, we go into different things as well. We could change around the textures, for example. On,
you could go into
well.
the terrain branch.
That's as well. We have a terrain generated thing as well. Let's see. I was going to materials.
Keep it, you know, there's a lot of background missing still, right? So we want to keep it so everyone can appreciate what's roughly happening there.
Right. So we might need the shader as well, actually, for this. Let's see. So as we saw it, oops, that's the wrong one. As we saw it when we were discussing materials and lighting and such, and shaders, was that everything within a material is basically what you set as uniforms for the shader. So the specularity, the textures, the opacity, and so on and so forth. So we made a structure that sort of defined this as a material, the have it there, yeah. Yeah, maps, so you can set textures for your shader, and you have values, which is just simple like floating values, and lastly we have vectors where you can set colors and such. So it's kind of limited in the fact that you can't really like give matrices as uniforms and stuff, but it's sort of covers the basis, I think, for most of our needs.
I mean, you can jank it. You can jank matrices with several vectors if you're really creative.
Yeah. So let's go into the subsurface scattering shader. It's quite long, but here we have all the different uniforms defined, and so you kind of need to match them up, which is well, sort of a limitation, but not really, because if you just remove all of these, it should still.
Yeah, you need to change the amount of values though to 1.
Oh, that's true. Good catch. It should still float. Yeah. So now it sort of lost its subsurface scatteringness because we no longer have those values defined for just that, because that's like these values, I think. Yeah.
Subsurface scattering, did you talk about this already? No, not yet, right?
Well, super briefly, just.
But it's this kind of, you know, if you shine a torch through your skin, that kind of thing, right? So that you see the structure of that. And they modeled this as well for the dragon, so that you can actually, it has a bit of a transparent feel to it.
Can you go to the scene with the 3 colored lights that circulates the dragon? Isn't that in one of the scenes?
Yeah.
Because that shows off the subsurface scattering really nicely.
Let's see.
So we had just one slide comparing BRDF and BSSRDF.
Yep.
So do you remember the one with BRDF only surface and BSSRDF light penetrating into the matter, having some scattering, and then coming back?
There you go.
Yeah, so we have this thing. Let me actually go into, there's one last asset kind we haven't really covered because it's not in the asset file, but we have a config file as well. We can override these. So the clear color of OpenVL, we don't want this to be blue anymore, because now we've verified that well, the mesh is loading correctly and stuff. So now we can actually set it to black. We should never have it black otherwise, or white for that matter. But now it's sort of verified, so let's reload it. Another thing I completely forgot to mention is actually the switching of camera modes, where did everything go? There we go. Okay, so now we have our orbital camera instead. It's sort of focused on one position, and this can be changed as well from the different scenes within the main camera, which mode you start in. You basically have field look and orbital, and we have the different camera options as well for field of view and stuff. Yes, that's that one. Yes. Yeah, did you want to show something specific with this, or?
No, I mean you can just change the cameras in the scene pressing tab, and then you just switch between all the cameras in the scene. That loops back to the one. You can also manually change. You can also manually change the camera mode with space, I think, to switch between free look and orbital.
Yeah, that's the one I mentioned as well.
Yep, and you can just move around and do stuff.
So, do you have any subsurface scattering for
this one?
This one, or just reflection? I think there. Oh yeah, a bit.
So you can see it quite clearly when.
Oh yeah, it
and
transmits.
specifically, or just now, I think you see it quite clearly. Yeah.
Oh yeah. It's pretty translucent.
It's like it's a porcelain dragon, right? So
Yeah.
you can see through it.
And yeah, there's also the directional light, which is the white light now. You'll see. But yeah, we have kind of find more cameras as well. Let's see. Let's just move it somewhere, or rotate it, I guess. Velocity. Does this actually work if you have velocity for the camera?
I think.
Let's
I
try.
don't remember. Maybe.
Okay. Tab was it?
Yeah.
Tab doesn't appear to do anything. It's broken.
I mean, if there's only one camera on the scene, then no.
Oh, but we have 4. Oh wait, this is the wrong scene.
Yeah, it's the wrong
Of
scene.
course. That's true. Let's run the correct scene instead. That's the wrong.
It's the wrong brush terminal.
Yeah. Oh yeah, we're on a different camera immediately. Let's see. Oh jeez, this is confusing.
Why is it? Wait, did you change the rotation of the camera?
Yes.
Oh god.
So the different axis,
I mean,
axis for input doesn't really work this time.
Yeah.
Yeah. But yeah, it just shows the different. So yeah, different cameras. Just have to be orbital. Yeah. I don't know. Anything you want? Any questions about this?
Yeah, that's right. Bring it back to the audience. Do you guys have any questions, or are you totally lost, or do you have any, questions regarding what they are doing or why they're doing it? That's the question I always ask them. They can't answer it up to now, but.
Did it inspire you?
Does that make sense what they're doing there? Yeah, please.
Well, we had already planned to try to make an engine of some sort because that was recommended by that guy.
Ah, Gunnar. Thank you. Thanks for pointing him out. Okay. You're no longer invited. Just kidding. But
Yeah.
I think it's important to appreciate the complexity, right? Because most of the stuff they're doing is in real time, right? So, I mean, of course, that's any real-time modification will most likely end up in some sort of error or, unpredicted state anyway. But it's really cool that you can actually modify and experiment basically with the system at real time, load models, change models, change properties. Because you know it from now, having built your first game, you know how tedious it is to actually change something, actually, right? And then do it in, specifically if you want to do it in real time. And now even using their own language on top of it. So basically they have their own specification, YAML specification they're consuming, and basically allowing it to completely to reload. So it's really nice. Super flexible model loader, right? Admittedly buggy, but you cannot push it so far. Right?
What did you change?
I added a buggy.
Why is it called exam?
That's also a good.
That shouldn't be too hard to fix. Come on.
So
Yeah,
it's
well,
in the config.
I think it's in the
exam.
config, yeah, so, can I? Shit, I can't really open that.
What?
No, I had some gifts in the in Discord. Like,
Ah.
one thing I don't think we showed off now is just like the scene with the. Let's see, I might have it actually.
You haven't shown
Skybox?
up a scene with a skybox yet.
Yeah.
Ah, yeah, that's right.
Let's see.
I think the standard scene, if you just launch cube.exe, I think it has a skybox. Yeah, there you go.
There we go. Nice. So this is sort of the ultimate test of our parenting system, where we have a solar system with, of course, the precisely modeled, accurate model of a solar system with a dragon.
That's a cat.
Actually, the only thing you probably should do nowadays to make it more realistic is to load a Tesla Roadster, right?
Yeah, that's it. Yeah.
For you.
No, but press tab a few times so you can switch the
Ah,
cameras.
that's true. Yeah.
Is
Yeah,
the background
parenting
just
is
a huge
That
texture?
is a monkey.
There's a monkey head.
But
Is the background just a
Suzanne.
texture sort of?
yeah, so the
It's
cool
a
thing
cube.
here is, which is kind of the thing I wanted to show in the GIF I have, is it's literally just a box with UV coordinates, and then I set the shader property to be like called on the other side. So we're just using the same model as for the, let's see, for this cube, I think.
I think you can almost see the seams if you look very closely at the corners of
Yeah.
the cube on a better monitor. Though,
Yeah,
you
this
see,
is
you see a seam over there, I think.
They're
Maybe.
incredibly visible.
Yeah. Yeah. So the light sort of breaks in different camera modes. That's one
yeah,
of the
and
two main inputs.
due to how the orbital camera works with It's doing a matrix calculation to figure out the offset depending on its rotation. Fancy-wancy matrix stuff. Point is the position is wrong in regards to what we send to the shader, which means that the specular light is calculated to be in the wrong position in regards to where the camera is. So in the orbital mode, it doesn't really work that well because of that. Yeah. I'm sure we could do some fancy math to figure out what the position actually is and then send that to the shader, but you know, that's work.
That's work. True. Any more questions? No?
The most important question, does everyone need to do that for their second assignment?
I mean, this is a D-level assignment.
Did you get a D for that one?
No, we got an A.
Well, you know, upon review right now, you probably should. Yeah. Anyway.
Yeah, the spectrum doesn't actually work. What?
Upon closer inspection. No, so that was probably one. I think the most creative kind of. I think almost out there, literally overkill kind of thing that people did, because they basically redid the entire graphics course from principle, right? So you know, redid models, have a dynamic loader, and basically all the stuff we didn't cover or only touched upon, the guys kind of explored in much more depth. So the idea is about the curiosity approach is to invite you to do things like that if you want to. Of course, you don't have to, of course, right? So you can do Pac-Man 3 perfectly fine. There's amazing solutions we had for that one as well. But it's just an inspiration. Okay, that's what you know we had. What's happened last year, kind of thing. Please.
We are probably going to try to make like a simpler engine.
Of course. The point is they're overscoped, right? So actually, from an achievement point of view, they're put way too much features, right? So sometimes it's better have fewer features, refine them, you know, make them more robust and so on, than going that far. So, but you know, they really want to push it, and they're still developing this thing. So,
Are we?
I think so.
Yeah. Oh, okay. Like every once in a while on a rainy day, I guess.
Yeah.
Yeah, we spent way too long time on this in regards to what was actually expected of us for this assignment. I used Toggle for the entire project and capped off at just over 100 hours on this project, which is, you know, a lot more than you probably should spend on this assignment. But if you want to, you can make something more overkill. It's always fun, question mark.
You know, but the point is you're invited to explore any direction, right? So you can look at data formats, you can look at rendering, they look at shaders and on object formats as well, right? And dynamic loading and lighting. So you kind of mixed everything up. You could kind of focus a bit more if you wanted to and only look at selected aspects.
Did we ever check if the tiny object loader was faster or slower than the string view loading of the? Okay, because I'm really curious about that one.
Good point, actually.
I should test that on you.
Yes.
How many people were in your group?
3.
Right.
The last one, admittedly, is.
He escaped our grasp.
He was
get an actual job.
He was a really good programmer, so yeah.
So you got the job before taking the 3rd year?
Yep.
Yeah.
Wow.
That's how good it was. So.
Didn't education, I guess. Oh. 2/3 so far.
Anyways, if there's no more questions,
I think that's sensible, right? So just give an intuition, so you guys are inspired. How many of you have committed to an idea already? Not explicitly formally, but at least, you know, mentally, you guys want to do something?
Yeah, we wanted to try to make an engine of the suggestions because that's useful for learning how things work.
Yeah.
And it will also be useful for exams apparently.
That's the main driver, right?
Yeah.
Yeah, okay. And honestly prevails, yes. But probably some important aspect regarding the engine is kind of figure out clearly what you want to do, right? What you want to focus on. So else you're torn in so many directions. How many people are on the team?
3.
3.
Are we allowed to be more, or are 3 the maximum?
Well, the idea, technically we are not particularly constraining, we would be happy with more. The problem is you want to ensure sufficient workload for everyone, because the last thing you want is that one person didn't get an opportunity to contribute enough and is alone in the assignment, in the exam, sorry. Right, because in the exam, that's on you, right? So whatever you pull out of learning, and the learning is happening in the assignment, is what you take away. So large groups may not be to everyone's advantage.
At least for me, the majority of the learning in the course was from the assignments.
That's the intent. That's how it's modeled. Yeah. So else we do a theory course. That's also incredibly interesting, but also incredibly boring. But here it's really about you investing time in learning. That's a good opportunity. So it's largely motivation. Other groups with ideas. Yeah, please.
Yeah, we're making a remake of Quake or do
yes, you mentioned that. Cool.
Yeah.
Cool. That would be interesting.
Yes. So we'll see how many features we get from you.
That's right. Also, it will be interesting to validate, right? Because we know the original. I think everyone knows no more Quake, right? So guys, yes.
The first one's not the latest.
No, yeah. So remake the latest. Back to the 80s, right? What was it? 88, right?